holy skedaddle. Let's go over some more homework answers. Are you ready? Here are the first 16. So why don't you go ahead and pause your screen and see how you did. Holy cow, there was one hiding from me. It also has 18. Man, just when you start to think that you can trust what you see. And then here are the last 6. Yes, yes, no, 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 yes. It's not nice. 3 of each, keeping everybody happy, right? All right, let's see what we were looking at last night. Inscribed angles, right? Copy and complete. If a circle is circumscribed about a polygon, then the polygon is inscribed in the circle, right? The polygon is in the circle. Each of its vertices would have to be on the circumference of the circle. Number 2, explain why the diagonals of a rectangle inscribed in a circle must be diameters. Well, here's the magic diagonal. Why would it have to be a diameter of a circle? Well, because by definition, a rectangle has nothing but right angles each corner. And those are, because of the inscribed rectangle, those are on the circle. Those are inscribed angles. Just a quick illustration here. That's an inscribed angle right there. It's made up of 2 chords. Okay, and so the measure of the angle, which we know is 90, um, would be doubled to get to the arc. And if it's 180, it's a semicircle, which means it had to be intersected by a, you guessed it, diagonal. And so, or a diameter. Sorry, I knew it was a D word. All right, let's move on. Number 3 is a direct application of theorem 10.7, which tells us that we have a relationship between inscribed angles and the arcs they intersect. It's a 2-to-1 relationship, or if you're going from the angle to the arc, a 1-to-2 relationship. Half of 84 is 42, right? I would love to do the same thing here, except I don't have the arc. So how am I going to get angle G if I don't have the arc? Oh, well, I know a full circle is 360 degrees. Never forget how many degrees are in a full circle. 360 minus 120, 240, minus 70, 170, 170 degrees, which half of 170 degrees, of course, is 85 degrees. There's G. I told you a couple minutes ago how important diameters were. Don't lose track of your diameters. Diameters are terribly, terribly helpful. And they always find semicircles for you. So NML is 180 degrees. And if this arc NM is 160, by subtraction LM is 20, which means skinny little angle 10 here. Be 10 degrees, right? Half of 20. Measurement of RS, well, because RQS is an inscribed angle, we're going to have to double it to get 134 degrees for arc RS, the measure of arc RS. Measure of VU, you're looking for this, okay? Well, I know that the arc TV is 60 degrees because it's doubled the inscribed angle 30. But then I'm like, well, how does that, how does that relate to this arc over here, right? I just told you 2 problems ago, diameters are your friends. Semicircle. Once you know that you have a semicircle here, just subtract from 180, and you should get 120, you'd think. There is another way of doing this, but it's kind convoluted, you would use triangles, right? If you finished off this triangle here with another chord TV, you know that because of the diameter, this has to be a right angle. And so that means that angle T here has to be 60 degrees by a subtraction from 180. And then angle T is an inscribed angle. Double that to get 120. Like I said, probably most people would not want to do it that way. This last problem, what's arc WX? We know that arc WY is 150. That's 75 times 2, since 75 is an inscribed angle. And then we just subtract um, from 360. So that's 260 subtracted from 360 is going to give us a cool 100 degrees. And that is the first 8 problems. Let's keep going. Number 9, what's the error here? Well, because of this diameter right here, I know that QSR is a semicircle. Okay, and that would make SR 80 degrees by subtraction, right? Except your buddy, let's call him Josiah, decides that they're going to use the inscribed angle 45, and they double it, and they get 90. So they're like, no, it's 90, and you're like, no, it's 80, and then you get in a big fight, and you don't speak for weeks. Well, the truth is, you were both right with your reasoning. One of these measurements must be wrong. So how could you correct this error? Well, you could either say that the inscribed angle is incorrect and make it 40, or you could say that the arc QS was measured incorrectly and it's really 90, or you could say that QR itself could not have been the diameter. That would have also explained why we didn't get 180 the way we did it. All right, 10, 11, and 12. Name 2 pairs of congruent angles. So really, we're just playing that game. Who's inscribed in the same arc, the same arc, the same arc? Who's inscribed in the same arc, right? Boop, 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 boop. So, angles A and B here are both inscribed in the green arc CD, so they're congruent by theorem 10.8. And then you could make the same argument with angles C and D being inscribed in arc AB. So there you go. Likewise, M and L are both inscribed in JKL, and angles J and K are both inscribed in arc ML, so those would have to be congruent angles. Getting the picture here. W and Z are both inscribed in XY. X and Y are both inscribed in WZ. That's a pretty big looking arc. I bet that one needs a third letter. It looks like it's a semicircle. Anyway, 13 is, it says that we should start using algebra, but this is one of those that I told you I really don't think algebra is necessary if it's a direct relationship. If it's a direct supplementary relationship, you can just say, oh, that's 85 degrees because 180 minus 95, 180 minus 80 is 100. So I would have been fine if you just did your work just like that. Now, on the other hand, when you start getting equations, well, like M isn't an equation, it's just a subtraction, isn't it? But here it's not. So we would need to say 2K plus 60 equals 180. Or I guess you could have just said if 180 minus 60 is 120, you could have said 2K is equal to 120 directly. Notice that when I subtract 60 here, I get the same equation. So either way, K is equal to 60. By the way, that means that the angles that are consecutive between the bases here are supplementary. That means that our little inscribed quadrilateral here EDGF is a trapezoid. Very interesting. Um, 15, once again, an inscribed quadrilateral. And so the opposite angles are going to be supplementary. So this time they don't give you the opposite angles. You're going to have to do a little more detective work. These are usually one of the most missed types of problems. Just to give you a heads up, you need to look at all the information. And let me show you what I mean. First of all, there's an easy piece of information to find by just noticing that there are 4 arcs around the circle and I have 3 of them. You could easily subtract from 360 to find the missing arc, JK. But this is all about inscribed angles. So for example, if I took, I think I'm going to focus on one, that even if we didn't have the 66, let's do one. So let's say that I had angle J here, which is this side and this side, right? This is angle J. Notice that the arc that it intercepts, I'm going to do a slightly larger arc here, is a combination of KL and LM, 240 degrees. 240 degrees. What that means is that the inscribed angle is half of 240. So it's going to do 120. Suddenly we have a relationship. 3A plus 120 equals 180 degrees, or you could get the supplement of 120 right off the bat. And here is your equation. Okay, so these aren't that bad. You just have to look until you find the inscribed angle arc relationship, which you know. Okay, now this one, there was another one I think we could have used. It would have been this. So I used those two. I didn't use these two, so that would have been angle K, right? Yeah. So it would have been this guy and this guy. Because even without the 66, once you have 66, you could use any inscribed angle you wanted. But even without the 66, I could have still used the 2 given arcs, 54 and 130, to get 184. And half of 184 is 92. And the supplement of 92, opposite angles of inscribed quadrilaterals are supplementary, is 88. So that's where the 4B equal to 88 comes from. All right, so 15, usually one of the most missed problems. Don't panic, just look at what you have and keep adjusting until you find the relationship that you need. All right, 16 was multiple choice. If ADC is a central angle and ADC's measure is 60, what is the measure of ABC? So this is just, do you know inscribed angles? So let's take a closer look at this. We have a one-to-one relationship between central angles, but the inscribed angle is half the central angle, and half of 60 is 30. So it looks like the answer there is B. And then down here, number 18. Yeah, it's just another direct relationship. We know that the inscribed angle is going to be half the arc. The arc is double the angle. So how do you want to do that? Do you want to do that 1/2, right? 1/2 of the arc, 12x plus 40 is 8x plus 11. This one's fine because 12 and 40 are both even numbers, so it works out quite nicely, right? However, what if one of those were odd? Now you're dealing with fractions, and most people aren't going to want to deal with fractions, so it's much safer to go in the opposite direction. Why not take the inscribed angle, or and then we know the arc is twice as big, so double it, double that guy. The opposite of multiplying by half is multiplying by 2, and that way you're guaranteed you don't need to worry about fractions until maybe the end. By the way, you get the same answer either way, right? You get the same answer either way. Okay, your choice. You you decide how to do it. So 20 through 25 were all kind of the same idea. How do you know that certain quadrilaterals can always be inscribed versus can't? Well, we have to use that opposite angle supplementary relationship. Number 20, a square, well, heck, a square is always going to be, four right angles, which means that the opposite angles will always be forced to be supplementary. So here's our circle, and here's our square, and I will be able to find a circle that inscribes that square. There it is, every time, okay, because of the 90-degree angles. Now, a rectangle also has 90-degree angles, and let me grab a rectangle for you. And so we'll also get always, 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 always. If the opposite angles are supplementary, it has to be, it's an if and only if theorem, right? A quadrilateral can be inscribed in circle if and only if its opposite angles are supplementary. So if they're always supplementary, it's always going to be inscribed. Now, a parallelogram is more interesting. Here's a parallelogram, and you can see that the opposite angles are congruent, but they don't have to be supplementary. And so unless your parallelogram happens to be a rectangle, that's not always going to be the case. So we aren't really keeping track of our score here, are we? My bad. This one was always, this one was always, this one would be sometimes. What about a kite? Well, here's what I know about a kite. I know that the non-vertex angles of a kite are congruent. We learned that first semester. So if those are 90, they would have to be supplementary. Otherwise, there's no way they could be supplementary. And even if they were 90, the non-vertex angles of a kite, these dudes, are never congruent. So what that means is it is impossible for a kite to be inscribed. Now, I guess I said these are never congruent, so if these are 90s, these couldn't be, but these could be supplementary. These could be like, let's say this was 100, and let's say this guy was 80, and then you got a 90 here, and a 90 here. Okay, so I guess we made one that might be. We could probably get that one to work. But in general, it doesn't always have to happen. The only way it can happen is if your vertex angles, non-vertex angles are congruent, are right angles. What was next? Oh, a rhombus. It's a rhombus. Oh yeah, here's the kite that fit. Good. So the rhombus is like a parallelogram. We know that it's equilateral. We know that its diagonals bisect each other, but its opposite angles do not have to be congruent. Only if it's a square does that rhombus become inscribable, right? So this one was, where'd my pen go? This one was sometimes, this one was always, this one was never actually. This one was never. No, if it's a square, if a rhombus is a square, it works. We'll say it's sometimes. And then an isosceles trapezoid. So an isosceles trapezoid isn't just any old trapezoid. An isosceles trapezoid is a trapezoid with legs congruent, so the base angles are congruent. And so, if A is say like 120, B would be 60, and so these would be supplementary, these would be supplementary. That would work. That's the only way, though, that it's going to work for a rhombus, because we know that these are always supplementary. But that doesn't mean that these guys are supplementary. Only if these are equal could it actually be supplementary. If A plus B is 180, A plus D can only be 180 if B is equal to D, which is why it only works for isosceles. So, for isosceles, it would be would be always. So there you go. Problems 20 through 25. Good thinking problems. I liked those. I'm sure you probably didn't like them as much as me, but hey, I am a math teacher. If you hadn't noticed. Okay, tomorrow we're going to finish that review sheet, and you're going to be still able to ask me questions. Remember, if you haven't submitted this, that means that it's past 9 o'clock in the morning and it's going to be late. So get it in as soon as you can. The longer you wait, the less points you get for the assignment. Okay. Talk to you tomorrow. Be well.